ice coating airplane wings, barnacles adhering to the hulls of ships, crude oil sticking to pipes while being channeled between storage sites. All of these greatly reduce energy efficiency by creating drag, which wastes energy and fuel moving things through air, water, or narrow pipes. These problems are all caused by the underlying issue of fouling, which occurs when unwanted substances stick to surfaces. To solve this problem, Wyss researchers took inspiration from the pitcher plant, which uses a unique nanostructured surface that holds tightly onto liquids to create a powerful non-stick, slippery surface which it uses to trap the insects it eats. Our scientists replicated this ability in the lab to harness nature's engineering for human use. Slippery, liquid-infused porous surfaces, or slips, consist of a nanostructured material infused with a lubricating fluid. These slippery surfaces repel almost any fouling material that could accumulate on a surface, from bacteria to ice, water, oil, dust, or other contaminants. Researchers have incorporated these surfaces into various technologies and applications, which are currently being commercialized. Adaptive Surface Technologies is using the slips coating as an additive to marine paints, which can be applied to the hulls of boats to prevent the buildup of barnacles and algae. Slips reduces the cost of boat maintenance and helps boats run more efficiently, thus reducing the use of fossil fuels. It also prevents damage to the aquatic environment, as other anti-biofouling coatings use toxins that kill marine life. This technology is also being used as a coating for environmentally friendly air conditioners, which is another major source of carbon emissions. The Wyss Institute's C-SNAP technology incorporates slips-inspired coatings into an evaporative cooling system that uses much less energy to cool spaces. It also uses water to achieve its cooling effect instead of refrigerant chemicals, which are 10,000 times worse for the planet than carbon dioxide. Medical devices implanted in the body are often fouled by bacteria and other biological materials. Ear tubes, which are commonly used for treating inner ear infections, often become blocked and must be frequently replaced, which increases the risk of permanent eardrum damage. Another Wyss team developed ear tubes coated with slips to keep the tubes clear and reduce the risk of infection. Medical devices that come in contact with blood are also subject to biofouling by blood components, which can cause life-threatening blood clots and infections. A cross-platform collaboration at the Wyss led to the development of a modified slips technology that could be applied to commercial medical devices. This led to the startup of free-flow medical devices, which is applying a slippery surface coating to a variety of devices, including hemodialysis shunts, catheters, and external life support systems to reduce the risk of blood clots and infections during medical procedures. By taking inspiration from nature and combining disciplines, the Wyss Institute is living our mission to transform healthcare and the environment by overcoming challenges in unexpected and unconventional ways.